Okay, let's finish this off. Okay, as you flip back to your notes from yesterday, let's make sure we're all on the same page. For the equation, y equals a times the sine of bx, how do you identify the amplitude? I'm on the previous page right at the bottom. I know, I'm just helping us remember. And then the period is 2 pi divided by b. Yep. And so that's what we need to remember. And you guys remember that sine and cosine have what shape? Like a wave. So let's try this one. Whoop. Here we are. Not algebra 2, but precalculus. So we have y equals sine of 4 pi x. We did the other two yesterday. We'll do these two today, and you guys will have full understanding. You'll have an awesome homework assignment. You will say, I love trigonometry. I love the graphs. They are interesting. You'll go home and you'll say, hey, Mom, what's your amplitude? Start talking in terms of trigonometry. So what is the amplitude of the first one? When I identify the amplitude, what do I do right after that? I mark it off on the y-axis as positive 4, as negative 4. There we go. What is the period? 2 pi divided by pi, which is 2. Very good. So now we're going to divide this up into 4 equal sections. Why do we divide it up into 4 sections? That models the 4 quadrants of the unit circle. So 2, divide in half to get 1, 1/2, 3/2, negative 1/2, yada, yada, yada. So I've divided up my vertical axis, y, and I've divided up my horizontal axis, x. What do I do after that? I have to identify my starting point and my direction. Where does sine start? 0, 4, negative 4. Where does it start? Sine starts at 0. Does it start going up or going down? Starts going up. Now this is positive, so it will continue to start by going up. So I will plot 0, 0. Where is it going to be at 1/2? All the way up at 4. How about at 1? How about at 3/2? How about at 2? And you can even back up over here if you want to provide a little bit more of the graph. And now you're going to use your very best handwriting, Nathan, and you're going to draw a nice sine wave here. And there's my graph. Looks pretty good. Any questions on this third graph? All right, let's do the last one. What's the amplitude? 2. So I mark off 2. I mark off negative 2. And then, what's the period? 2 pi divided by 1/3. 6 pi, very good. Divide in half to get 3 pi. Divide in half again to get 3 pi over 2. So what would that other one be then? Oh boy. So 3 over 2 is like 1.5, right? 1.5 plus 1.5 is 3, plus 1.5 is 4.5, or 9/2. 9 pi over 2. So I've divided up my horizontal axis. I've divided up my vertical axis. Now I need to identify the start point and the direction. Is it going to start at 0? Is it going to start at 2? Is it going to start at -2? -2. Cosine normally starts at 1. It's amplified by 2, so it would go up to 2. And because it's negative, it will be reflected over the x-axis. Vertical reflection over the x-axis. So it's going to start down here. And where's it going to be at 3 pi over 2? 0. And at 3 pi? 2. At 9 pi over 2? And at 6 pi? Now, the last thing I want to do before I give you your assignment is I want to show you how that looks like on your graphing calculator. I didn't realize this. Nobody showed me this. It's pretty intuitive. You probably should figure it out. But I was student teaching, and some of my calculus students, when I was student teaching, start graphing the sine wave. And as they did, they were changing their window to look a certain way, and it made a lot of sense. So I do learn things every year, and a lot of times I learn things from you guys, which is good. So first thing we do is we go into y equals. Make sure your plot's off. People have problems with that first hour again. They didn't turn their plots off, so invalid dimensions. There's all sorts of problems. So we're going to type in -2 cosine of x over 3. That's my function. Now, when I'm working with graphs, when I'm working with similar values like this, anything that gets plotted on a number line, I want to be working in radians. But when I'm solving for triangles, then I work at degrees. So if you go into mode, make sure that you're working in radians. Otherwise, your graph will look very, very strange. So I'm working in radians. Can you imagine if we were working in degrees? I mean, 6 pi, that's like, what, 1,080 degrees? That's a lot. We don't want to do that. So we're working in radians. Now what we need to do is change our window. Tell me, what is the smallest x value we have here? -3 pi over 2. So you go -3 second pi divided by 2. Let's type it in. It'll convert it to a decimal. What's the maximum value we have? So 6 pi. -3 pi over 2. What is our increment? What's our scale? 3 pi over 2. So 3 second pi divided by 2. What's our maximum y value? 2. What's our minimum? And so now that you change those, it's going to give you a picture that looks, hey, what? Charlie. Okay, x min is -2, x max is +2. Thank you, Charlie. The x scale, so 3 pi over 2. That's what we're increasing by every time. 3 pi over 2. Now as I press graph, look at that. Well, I think it's exciting because it looks identical to what I drew. We don't need graphic technology to draw this stuff. We know how to do it just by hand in like 2 minutes. Because you're super smart. I'm more amused than you are. There's your assignment. If you could only see the applicability. Light travels like a wave. Voice travels like a wave. Everything that is real in this world can be modeled mathematically. Whoever who's watching this video, we hope you have a great lunch.